Good morning, and thanks. I'd like to thank the committee for inviting me to speak here in North Bay. As Jay said, I grew up in the North Bay area, and it's always good to come home, especially talk about something that I hold so dear. I'm now with as of last month, with the Ministry of Northern Development, Mines and Forestry since the switch over, and I am out of Sault Ste. Marie. And today I'll just talk about the potential in Ontario. But I understand there's some folks from outside, so I'll set the context a bit. And I noticed it wasn't on the agenda, so I'll take the liberty and add a couple of slides about policy, since that's the place where I work in Sault Ste. Marie. Then I'll get into some of the information we use to estimate the supply, and then go on to talk about factors that affect the supply. So I'll make the distinction between a theoretical volume that's out there, and then get into what the potential supply could be. So just to set the stage, Ontario is a large province with 108 million hectares, and there's a zone across the middle part of the province where we actively manage the forests of Ontario, and that's called the Commercial Forest Management Zone, or the zone where we have environmental assessment coverage. The province is divided into about 48 management units that like I say, we conduct, we prepare for forest management plans and determine the sustainable supply of right now. Well, and we determine sustainable supply, which right now in terms of volume includes just roundwood, but we're moving forward to include biomass as a component of the forest management plans as well. So that the plans are developed at a local level, and the harvest level, regeneration level, and it is set, and as we move forward with them. A bit more of the stage, as you know, the forest industry is in a bit of a downturn right now. This slide just shows that, for example, in the northwest region, that middle bar on this bottom right graph shows that only 25% of the mills that consume more than 25,000 cubic meters per year are still running there right now. The northeast and the southern region are a bit less impacted, but still the overall effect of closures and temporary shutdowns is immense. So we've taken a role here in government to we're trying to promote the bio industries and bioeconomy, and we're trying to contribute to the evolution of a green economy by facilitating sustainable use. Some of the drivers, I'm not going to go through all this. This will be available on the website after. But I'll just touch on a couple of them, like the renewable, the Green Energy Act and the new feed-in tariff. It's a big driver, and it creates incentives for industry to get into production of power. There's other things like carbon fuel standards and ethanol growth funds, et cetera, avenues where industry can go in this new forest bioeconomy. There's also the Ontario Power Generation's phase out of coal by 2014, so that's driving some interest in the bioeconomy, and MNR had loan guarantee programs and the Fourth Sector Prosperity Fund. You'll hear later on today about CRIBE as well. And then there's also further discussions on a carbon tax and trade, other initiatives that would serve to incent the bioeconomy. I'll just throw this up for a minute. This is just my picture of the near-term future. An associate of mine, Indrajit Majumdar, an economist in our section, and I put this picture together. The first 13 years on the graph show actual consumption by the major sectors in the province. and the vertical line is where we are today. Obviously, the last 3 years has been quite a downturn in the amount of wood consumed. And then we took some information from RISI, and which shows projections over the next few years of where the forest sectors are going to go. And you see the bottom orange line that goes up from around 300,000 today to about 5 million over the next 12 years. And that's where we think the bioeconomy or the biofuels will potentially go if we do things right. It's not limited by that. This is just an estimate and based on a RISI projection for global demand, and Ontario is kind of a piece of that. So it fits in well with recovery in the forest sector. So that's my policy piece. I'll move in now to what I think what we're talking about and how much is out there and how we define how much is out there. So we've defined forest biofiber as trees and parts of trees from the crown forest that have traditionally not been utilized. So it could include unused merchantable trees that get left, and tops and branches as well. So we've had about 140 years of information on how much volume there is in the stem portion of the tree, because we've had crown stumpage and dues payable on that, and so we have a great system in place for determining how much volume there is in the bole of the tree. But only recently have we started to look at, okay, well, how much volume is there in the rest of the tree? So we went through the literature. I noticed that a few people here today that have, like Denis Cormier as well from FAIR, who we've gone through this literature and the allometric equations that are out there to define how much mass there is in a tree. So like I said, we know how much, we have a great understanding of how much volume there is in the bole portion of the tree, that brown portion. But the twigs and foliage, branches, bark and unmerchantable, those were parts that we just left in the past. So we, and Denis, this will look familiar to you, we put together, and we've updated it a bit, but we've put together these allometric equations so we could define each major tree species in Ontario and by its subcomponents. So like I say, each tree species has a unique equation associated with it, so we can define how much volume there is in the tops and branches and limbs and stem. So when we do that and we put together, and as I say, every tree species in Ontario, this is a depiction of 11 different species. Every tree species is unique, and then every tree species in association with another and as part of a stand is also unique. So there's a lot of variability when we come up with these estimates of potential volume that's there. But when you put it to, when you look at the equations and you put an average tree out there within that range, you come up with factors that we can then apply against that bole portion of the tree. So, for example, if you harvest 1 cubic meter of black spruce, the SB there, then you could expect another 50% or another half of a cubic meter of branches and tops and limbs. And again, this is an average harvestable tree. And for red oak, for example, in the bottom right, if you take 1 cubic meter of red oak, you can expect 1.28 cubic meters in additional volume of biomass fiber. So again, there's a lot of variability in these numbers. I just put up an average tree situation here, but that gives you an idea of where we're starting from. We've also undertaken studies where we've, to kind of bring this down and calibrate some of these allometric equations, we've looked at a full tree versus a tree length. So the same trees, we weigh them before and after we shed the branches, so we come up with some, trying to calibrate those numbers that we get out of the scientific equations. I'm going to get into some of the numbers now, and I always throw some caveats out there because I'm from government and we want to make sure that you're not going out and making business plans and you know, based on numbers that we're presenting here. I'm just going to present some theoretical volumes. So they're based on those allometric equations. And then I haven't reduced them for any other factors, which, well, I'll talk about after I present the numbers. And we're also holding a stage competition for a wood supply. Our minister will announce, you know, some of that information. But there's a competition on right now for wood supply in Ontario. And the numbers I'm going to show here probably won't match that because there's a number of other factors that go into the production of those numbers for that competition. So I'll just start with, I think Bob mentioned it, low-hanging fruit, and I like that term because there's about 600,000 cubic meters that still go to landfills each year, and that from a lot of these small mills in Ontario, there's still a lot of material that's flowing to landfill. So that's there. As far as potentially available roundwood volumes, each year in the province, traditionally over the last number of years, we've harvested about 20 million cubic meters, but the allowable cut on an annual basis was over 30 million cubic meters. So there's about 10 million cubic meters a year that we don't harvest currently. And if we did harvest the 30 million cubic meters and you apply those allometric equations to that 30 million cubic meters, that would allow us to harvest an additional 18 million cubic meters, or 18 million tons if you want to put it in tons, green tons, of biomass fibers. So that equates to about 28 million cubic meters annually that we don't harvest, or that's a potential volume. Another supply, and I know other panel members are going to talk to this, but is from private lands, and because we harvest about 3 to 4 million cubic meters from private lands, that could equate to another 2 million cubic meters of potential biomass. So like I said, we have to move from theoretical volumes to a potential supply. So there's a number of factors that affect the supply, and they're the 3 pillars of sustainability. Plus, I've added data and some uncertainty around our information. So, like I say, in terms of the social, there's, you know, and I think again, Bob mentioned it this morning in his talk too, is what's the best end use for this? Are we going to let it all go for pellets, or are we going to incent some other investment in liquid transportation fuels and chemicals and heating as well? There's other policies that come into play as well, community stability as well. Other factors in terms of the environment, obviously government, we're the stewards of the resource on Crown land, so we put out guides, and there's no exception for biomass extraction. We need to be cognizant that we have to maintain site productivity and biodiversity. We have to take into consideration things like species at risk and how we're managing carbon. So those are other factors that would serve to come into play when we come up with a final supply number. There's a number of economic factors, and I've just put some of the bigger ones here. The global demand, energy, labor costs, Canadian dollar, all factors that come to, and Jason would know that a lot of these factors come into play when you go to determining a supply. The data and information, of course, and I think colleague Murray's going to talk about this a bit later on today. There's how accurate is our inventory, because all estimates are based on that base. Growth and yield assumptions and research and infect and disease. So what does it all mean? I don't want you to go away thinking there's 28 million or 30 million tons available annually. So when you take the theoretical volume run it through this filter of social, economic, environment, and data uncertainty and risks associated with some of those management decisions, we think there's, and we're still working on those numbers as science evolves and as we move forward. So we estimate that the supply would be somewhere in the range of 10 to 16 million cubic meters per annum. I just had one more slide, but no. There we go. So thanks. Any other questions? I'm available on the through the government network. Thank you.